In the last few years, the construction of new public nursery school buildings has been carried out in an energy and environmental way in Italy. Thus, more designers have been called to improve the thermal interior comfort and to reduce the building environmental impacts during its whole life. The public nursery entitled to S.Dissegna is one of these new buildings. Many public administrations assumed the sustainability as one of the main criteria according to which developing the territory governance. Lots of them began thinking, planning and realizing public works, with particular attention to educational buildings, able to answer the criteria of sustainability, healthiness and environment friendly. In some Italian regions, such as in Piemonte, an energy and environment assessment tool had been introduced in order to evaluate and select the deserving contribution projects on the basis of energetic and environmental characteristic performances during the project and operational stage. In particular, the environment assessment tool is the Protocollo Itaca, based on SB method of ISBE. The Itaca rating score for the analyzed building is 3.4, which can be considered a good score, since the highest score is 5. The public nursery S.Dissegna is located in Poirino, that is a small municipality between Torino and Asti in Piemonte. The building area covers almost 1,600 square feet. It is located in a quiet residential area. It is next to an under-construction infant school and behind a secondary school. The nursery can accommodate 35 children, aged 3 months to 3 years, divided in 3 sections, lattanti, divezzini and divezzi. The building has only a ground floor and it has a central partially green area and a back playground area. The whole building is divided in 4 main areas. The first one is a common area that includes hand-painting laboratory, meeting room, medical room, kitchen with storage, offices and toilets for the staff, and the other 3 areas accommodate the different groups of children. Passive design strategies were considered in order to control the solar gains, and a careful design was also placed in the choice of plants, coming to get a low energy demand, heating and lighting, and a good level of indoor comfort during the operational phase. Renewable energy systems, such as solar photovoltaic panels and solar heating collectors, a rainwater collection system, a lighting dimmer system, and a lightning protection system, has been designed and built. Currently, the annual energy consumption estimation for school buildings in northern Italy is about 130 kWh per square meter for heating, and about 70 for artificial lighting and electrical uses. These numbers underline the necessity of a sustainable energetic management and, in some cases, energy refurbishment. In this case, the primary energy demand for heating and hot water production turns out to be 45% compared to the Italian legal limit for 2008. Moreover, this energy demand is further reduced by the introduction of on-site renewable energy devices. The whole building was constructed using environmentally friendly and recyclable materials, when possible, in order to minimize negative impacts on humans and on the environment. The load-bearing structure is made of wood, a natural and renewable resource, biocompatible, reusable and recyclable material. Walls plug are made of waste wood boards, hemp canaf fiber insulation panels, plasterboards and lime plaster. A ventilated roof has been introduced as a passive design strategy in order to reduce summer loads and maintain the insulation material dry. From an energy point of view, the building envelope has a good level of insulation in order to minimize the thermal leakage and reduce the heating consumption energy. The thermal loss level of the wall is about 1/5 of the Italian common wall of the years from 50s to 80s and about a half of the Italian common wall of the time of the design stage, 2007. Furthermore, the external wall is only 24 centimeters thick instead of about 38, which is the Italian common building system. Low emissivity double-glazed windows with argon have been installed. In this way, the thermal losses have been reduced by 60% compared to a normal double glazing window and by 20% compared to mandatory law requirements at the time of design. The building is equipped with two gas-fired high-efficiency condensing boilers. A radiant floor heating system was planned. It works at low temperature and avoids the stratification of hot air to the ceiling, phenomenon which could be particularly evident in rooms with such a high ceiling, and it provides a good level of indoor comfort due to the floor temperature. Children are often on the floor. Solar heating collectors produce domestic hot water, 54% of the demand, and have been integrated with the radiant heating system. A mechanical controlled ventilation has been installed. It can change continuously indoor air. Two sensors of carbon dioxide collocated on the exhaust air dust determine the quantity of air exchange per hour in order to have always a good level of air quality and a low level of pollutant. Particular attention has been paid to design the lighting system. Energy-saving lamps were provided. The presence of power regulation lamps in relation to natural light levels reduces the amount of artificial light needed to achieve a certain level of illumination satisfaction. Furthermore, switching devices based on human presence sensor have been installed in the toilets. Solar photovoltaic panels for an annual production of about 2070 kilowatt-hour have been installed. Another important environmental aspect is the correct and conscious use of drinking water. The project introduced a jet mixer, dual flush toilets and a rainwater harvesting for irrigation and for non-drinking water use as toilet flushing. The rainwater collection system on the roof and the rainwater storage have been designed. Two tanks, each of 4,800 liters, have been designed and placed underground in the court.